So in this lecture, we will discuss an application of stack, that is the evaluation of an arithmetic expression using Polish and reverse Polish notation. Okay, so you know that an arithmetic expression like 3 plus 4. Okay, so this arithmetic expression involves some operator. Okay, in this expression, plus is an operator and it has two operands, 3 and 4. Okay, so result of this expression is 7. 3 plus 4 equal to 7. Okay, so this particular notation of arithmetic expression is called infix notation because the operator is written between two of its operand 3 and 4. The plus is written between operands 3 and 4. So this is called infix because the operator is written between its operand. Okay, so there are other notations in which the operator may be written either before its operands or after the operands, right? So, so we will discuss them and how the arithmetic expression written in those other notations are evaluated and transformed from one notation into another. And all of these tasks requires the usage of stack. So stack is, although stack is a very simple data structure, but it is a very important tool and it is used in several critical applications. So we will discuss 3 or 4 applications. So the first one we are going to discuss today, that is the evaluation of arithmetic expression written in different form of notations. Okay, so let Q be an arithmetic expression involving constant and operations. Better is operator, right? So here 3 and 4 are constant in this expression, operands, and plus is an operator. Find the value of Q using reverse Polish, which is also called postfix notation. So we will see in the next slides what the Polish notation or a reverse Polish notation means. Okay, first consider an arithmetic expression written in infix expression. So in the infix notation, the operator is written between its operands, right? So now consider this expression which is in the infix notation. Okay, and this symbol is for the exponent. Okay, this is plus, this is multiplication, minus sign, and division. Okay, so we are using these 5 operators. Okay, exponent, plus, minus, division, and multiplication. And you can see that in this particular arithmetic expression, we haven't used any bracket. Okay, so if there are no bracket, then you must specify some rule which indicates how the different operators will be evaluated. Okay, in which order the different operators will be evaluated, right? So we assume that, and these rules are called precedence rules, right? So we assume that there are some order of precedence in which these operators will be evaluated. Okay, the exponent operator is given the highest precedence, and after that division and multiplication, right? And after that plus and minus. So we define 3 levels of precedence. Okay, the highest precedence is given to the exponent operator, then division and multiplication, then plus and minus, right? So division and multiplication has the same level of precedence, and similarly plus and minus also has the same level of precedence. Okay, so there is uh, if there is if there is an expression which has uh, both plus and minus, okay, and then how will you decide which operator will be evaluated, right? So for that, we define the second rule, that is, if there are operators which are at the same level of precedence, those operators will be evaluated from left to right. Right. So we have defined two rules to decide the order of evaluation of different operators. First rule is that we define different levels of precedence. Okay, exponent has the highest precedence, then then multiplication and division, then plus and minus, right? So the highest precedence operator will be evaluated first, then the next highest precedence evaluated will be evaluated first, and then the next highest precedence level operators will be evaluated next, right? And if there are operators which are at the same level, then we will use left to right evaluation. That is, first that operator will be evaluated which is at the left of the expression. Okay, and then we will be evaluating from going to right from the left, right? Now consider this expression which is in the infix notation, right? So 2 exponent 3 plus 5 multiplication 2 exponent 2 minus 12 divided by 6, right? So first, this is basically, if there are if there are parentheses in this expression, there will be no confusion. Okay. For example, if this is written as 2 exponent 3 within bracket plus 5 into 2 exponent 2, right, minus 12 divided by 6, right? Now there is no confusion. There is no need of any precedence rule. Okay. But if you don't have to specify the parenthesis, position of parenthesis, then there might be confusion. And to remove those confusion, you must specify some precedence rules. We have defined two precedence rules. Now apply these rules for the evaluation of this arithmetic expression. Okay, so uh, those operator will be evaluated first, which has the highest precedence. The highest precedence has at the highest precedence level we have the exponent, right? So 2 raised to the power 3 is 8, and 2 raised to the power 2 is 4. Okay, so 2 raised to the power 3 is replaced by 8, and 2 raised to the power 2 is replaced by 4. Okay, rest of the expression remains same. The next precedence level is uh, this level which has multiplication and the division. Okay, so we have one division and one multiplication, right? So we have two operators which are at the same level. So these operators will be evaluated from left to right. So at the leftmost we have this multiplication operator. So 5 into 4 will be evaluated first. So 5 into 4, 20, and 12 by 6 is 10. Okay, now in this expression we have only two operators plus and minus which are at the same level. So again we will evaluate them in the same order, left to right. So leftmost operator is plus, so 20 plus 8, 28, then minus 28 minus 2, 26. Okay, so if there are no parentheses in an infix notation of an arithmetic expression, then using these two precedence rules you can evaluate correct, right? So now what are police notation? Okay, so we have discussed infix notation. Operator symbol is placed between two of its operand. Okay, so a plus b, the operator plus is kept in between its operands a plus b. Okay, c minus d, e multiply f, g divided by h, right? Okay, now consider this expression a plus b into c. Okay, so there is ambiguity whether to evaluate plus sign first or multiplication first, whether to evaluate plus operator first or multiplication first. Okay, so this can be resolved in two ways. We have already discussed this. Okay, either use parenthesis. Okay, so if you put parenthesis like this, a plus b between the parenthesis, then multiply it by c. Okay, and this you can also put b into c within the parenthesis and then add a to it. Okay, so these two are different expressions, a plus b into c and a plus b into c. These are different expressions, right? So one way to resolve this ambiguity is either to use parenthesis, and the second way is you define different precedence rules, right? So this is one set of precedence rules. Other set of precedent rules can also be defined. For example, in some programming languages, some operators are evaluated from right to left, and some are evaluated from left to right. Okay, and here in this particular case, we have considered a very simple example which have only 5 operators. Okay, there are more operators, so more level of precedence also defined, right? Okay, so this is infix notation. What is Polish notation? In the Polish notation, the operator symbol is placed before its operands. Okay, so a plus b, which is the infix notation, the corresponding Polish notation of this infix expression is plus ab. Okay, operator plus is kept, is placed before its operands a and b, plus ab. Likewise, minus cd multiply ef divide gh, right? Operator comes before its operand. Okay, Polish notation is also frequently called prefix notation. The Polish notation of prefix, because the operator is placed as a prefix, comes before its operands. Okay, so infix expression to Polish notation. Okay, so for example, this is the infix notation. Here we have used parenthesis, so there is no need to use the precedence rules. Okay, so you can find the corresponding Polish notation of this infix expression very easily. How you start evaluating the expression starting from those sub expression which are written within the parenthesis. Okay, so a plus b, the first convert a plus b into corresponding Polish notation. So here the operator plus will come before its operands a and b, so plus ab, right? And you write this plus ab within big bracket. Okay, and this indicates that whatever written within the big bracket is a single operand now. Okay, so this multiplication sign has two operands. First operand is this, okay, which is written within the big bracket, and the second operand is this c. Okay, so now what will you do to convert this expression into the corresponding Polish notation? You will first write the operator plus, then you will write the first operand, which is plus AB, then you will write the second operand C. Okay, so this is the corresponding Polish notation. This is the corresponding arithmetic expression in the Polish notation for this infix expression, right? Similarly, you can write the corresponding Polish notation for this a plus b into c. Okay, the same procedure. First, consider those that subexpression which is written within the parenthesis. So b star c will be converted first. So it will be converted into multiply bc. Okay, and you write this within the big bracket to indicate that this whole sub-expression is an operand now. Okay, now the plus operator will be written first, then the first operand a, and then the second operand star bc, right? So now you can see that, okay, if you remove parenthesis from these two expressions, okay, then these expressions are same, a plus b into c. Okay, but since we have used the parenthesis, right? So the corresponding, the Polish notation is different. Okay, for a plus b into c, it is multiply plus abc, and for a plus b into c, here b into c is within the parenthesis. The corresponding Polish notation is plus a into bc, right? Okay, so obviously you can see that since these two expressions are different, okay, so the corresponding Polish notations are also different. Okay, so if you remove parenthesis, then these two expressions are same. That is, the order of all operators are same in both the expression, and order of all the operands are also same. Okay, but this is not true for the Polish notation of these expressions, right? The order of operator is different. Here multiply comes first, then plus, and in this first plus comes and then multiply, right? So the advantage of the Polish notation is that there is no need to use parentheses. There is no need to use parentheses, right? So the Polish notation itself indicates the order of evaluation of each operator. This is the advantage of the Polish notation. The infix notation needs e- either use of parenthesis or use of some precedence rules. Polish notation and reverse Polish notation does not require any such requirement. There is no need to use either precedent rules or parentheses, right? Consider this example also. Okay, so a plus b will be converted first, then c minus b will be converted next. Okay, now this division operator has two operands. First one is this one written within the big bracket, and the second operand is this one. Okay, so the division will be written first, then its first operand, then its second operand. So this is the corresponding Polish notation expression. The fundamental property of the Polish notation is that the order in which the operations are to be performed is completely determined by the positions of the operators and operand in the expression. Okay, one never needs parentheses or precedent rules when writing expression in the Polish notation. So this is the advantage of Polish notation. What is reverse Polish notation? Okay, in the reverse Polish notation, operator symbol is placed after its two operand. Okay, so a b plus, here plus sign comes after its operands a and b, so it is reverse Polish notation expression. cd minus ef multiply gc divide. Okay, one never needs parentheses to determine the order of the expression in any arithmetic expression written in reverse Polish notation. So for both the Polish notation expression and reverse Polish notation expression, we don't need to specify the position of parentheses. They are automatically determined. Okay. Reverse Polish notation is also known as postfix notation or suffix notation. Okay, because here the operator is used as a suffix, comes after its operand. Okay, so a computer usually evaluates an arithmetic expression written in fixed notation in two steps. First, it converts the expression into postfix notation, and then postfix expression is evaluated, right? So in the first step, the infix expression is converted into the equivalent postfix expression, and in the second step, that equivalent postfix expression is evaluated. Its value is found. Okay. So first we will discuss these algorithms. In fact, in both these two steps, a stack is used. Okay. So first we will discuss the second step, that is the evaluation of postfix expression, and then how we will see that an expression written in infix notation can be converted into equivalent postfix notation expression using the stack. Okay, so first we will discuss the evaluation of a postfix expression. This is the algorithm to find the value of an arithmetic expression P written in postfix notation. So P is the arithmetic expression written in written in postfix. Okay. So first step, add a right parenthesis at the end of expression P. So this act as a delimiter or sentinel which indicates the end of the arithmetic expression. Now scan expression P from left to right and repeat steps 3 and 4 for each element of P until you found the sentinel right parenthesis. Okay, until the right parenthesis is encountered. Okay, so steps 3 and 4 are to be executed repeatedly until the right parenthesis is encountered. So step 3, if an operand is encountered, put it on the stack. Okay, we are considering 5 operands. Sorry, okay, this is about the operands. So A, B, C, D, like. So if an operand is encountered, simply put it on the stack. Again, obviously in the stack you can perform, put it on the stack means push into the stack, because any element can be added to the stack only at one end, which is at the top of the stack. So this is step 3. Step 4 is if an operator, if any operator, okay, here we are considering only 5 operators: exponent, divide, multiplication, plus and minus. Okay, so if any of these 5 operators encountered, then remove the 2 top elements of the stack, where A is the top element and B is the next to top element, right? So for example, say this is the current position of the stack. At the top we have A, and the next to top element is B, and below it we have some other elements. Okay, so if an operator is encountered, we remove the 2 elements, top 2 elements A and B, where A is the top element and B is the next to top element. Evaluate B operator A, right, and place the result of B operator A on the stack. That is, this value, after the evaluation, this value will be pushed onto the stack. Okay, so after pushing it on the stack, this will be the stack position, right? So steps 3 and 4 will be evaluated repeatedly until the whole expression P is scanned. Okay, until the right parenthesis which is added at the end of expression P is encountered. Okay, so once the whole expression is scanned, you set the value equal to the top element of the stack and then exit, right? So uh, in summary, we have added right parenthesis to the at the end of the P. Then we start scanning the expression P from left to right until the whole expression is scanned. Okay, step 3 and 4 are to be repeatedly performed. If an operand is encountered, then we have to simply put it on the stack. If an operator is encountered, then we remove top 2 elements and evaluate B operator A, where A is the top element and B is next to top element, and we put the result of B operator A again on the stack. Okay, now consider this example. So this is an expression written in postfix notation, and this is the equivalent in fixed notation expression. Okay, 5 into 6 plus 2 minus 12 by 4. So if you evaluate this, what will be the value? This is 5 into 6 plus 2 is 8 minus 12 by 4 is 3. Okay, so 5 into 8, 5 into 8 is 40, minus 3, that is 37, right? Now, evaluate this postfix expression using the algorithm. So this is expression P. So first step is you add a right parenthesis at the end of expression P. Okay. So we put the right parenthesis at the end of expression P. Okay. So we have total 10 symbols, right? So some symbols are operands, some are operators, and one last symbol is the right parenthesis. Okay, so this is the expression P. We have added right parenthesis to it at the end. Now, this table shows the execution of the algorithm using stack. Okay, so this column represents the number of signals, the position of symbol scanned, first, second, third, right? And this is the value of the symbol, and this is the stack. Okay, so and at the left we have the bottom of the stack, and at the right we have the top of the stack. Okay, so instead of showing the stack in the vertical position, we are showing it like this in the horizontal position. Okay, at the left we have the bottom of the stack, and at the right we have top of the stack, right? Now consider the first symbol. The first symbol is 5, right? So 5 is an operand, right? So if an operand is encountered, put it on the stack. The 5 is put on the stack. Okay, that is you push 5 onto the stack. Okay, now stack has initially stack was empty. After pushing 5 into the stack, we have one element at the top of the stack, 5, right? The second element is 6. Okay, 6 is also operand, so 6 will also be pushed onto the stack. So after 5, 6 is pushed, right? Now consider next element, which is 2, right? So 2 is also operand, it is also pushed onto the stack, right? Now next element is plus, it is an operator. So when an operator is encountered, what will you do? Remove the top two elements of the stack, where A is the top element, B is the next two element. Evaluate B in B operator A and place the result back onto the stack. Okay, so top element 2, next top element 6, right? And here the symbol is plus. 6 plus 2 is 8, right? So this evaluated result 8 is pushed back onto the stack, right? Now consider the next symbol, which is multiply. So multiply is an operator. Again, the same step. 8 is the top element and 5 is the next top element. Evaluate B operator A. Here operator is multiply. 5 into 8, 40. So 40 is pushed back onto the stack, right? Next element is 12. So 12 and so it is an operand, so it is simply pushed onto the stack. 4 again, it is pushed onto the stack. Now division, okay. So it is an operator, so you will pop the top element, which is 4, next to top element, which is 12, perform 12 divided by 4, it is 3, and this result will be pushed back onto the stack, right? Next symbol is minus, so it is an operator, so again same procedure will be adopted. Top element is 3, next to top element is 40, okay, and the symbol is minus, operator is minus, So B operator A, that is 40 minus 3, it is 37. So it is pushed back onto the stack, right? Now next element is parenthesis. Okay, so Polish notation expression does not have any parenthesis. This is the parenthesis which have added in the first step at the end. So this indicates the end of the expression. So when right parenthesis is encountered, it means that we have already scanned the whole expression, and now we exit the algorithm, and the value of the Polish notation expression is that value which is at the top of the stack, that is 37. Okay, so this is how an expression written in Polish notation is evaluated using the specified algorithm. Now, okay, now we will discuss the second step. Sorry, first step. We have already discussed the first. We have already discussed the second step, that is evaluation of postfix expression. Now we will discuss the first step, that is how an infix expression is converted into the equivalent postfix expression. Okay, so we have an expression written in infix notation Q. We are using only 5 symbols: exponent, plus, minus, multiply, division, and we have defined 3 level of precedence. Okay, the first level is for the exponent, second level is for the multiply and division, and the third level is for plus and minus, right? Now this is the algorithm. Q is an arithmetic expression written in fixed notation. This algorithm finds the equivalent postfix notation. Okay, first step, push left parenthesis onto the stack and right parenthesis to the end of Q. Second step, scan expression Q from left to right and repeat steps 3 to 6 for each element of Q until the stack is empty. Okay, 3 to 6 are to be repeated. Step 3, if an operand is encountered, push it onto the stack, onto the expression P. Okay, here P is the postfix expression, okay, which is the desired output. So P is the postfix expression, Q is the infix notation. So if an operand is encountered, that operand is added to the postfix expression P. Step 4, if a left parenthesis is encountered, that left parenthesis is added to the stack, pushed it onto the stack. Step 5, if an operator is encountered, then repeatedly pop from stack and add to expression P each operator from the top of the stack which has the same precedence as or higher precedence than the encountered operator. Okay. So if an operator is encountered in the expression Q, then we repeatedly remove operators from top of the stack if there are some. There might not be some operator on top of the stack, and in that case we will not be doing anything. But if there are some operators at the top of the stack at that time, then we check its precedence. If the precedent is same as the operator encountered, or it has the higher precedence than the encountered operator precedence, then that operator will be removed from the stack and will be removed from the stack and added to P. Okay, and after all the operators which are at the top of the stack and has either same or higher precedence than the encountered operator, we add that encountered operator to the stack. This is step 5. Now step 6, if a right parenthesis is encountered, then repeatedly pop from stack and add to P each operator on the top of the stack until the left parenthesis is encountered. Okay. So if a right parenthesis is encountered, then repeatedly pop from stack and add to P each operator on the top of the stack until the left parenthesis is encountered. Okay. And you remove the left parenthesis. That left parenthesis is not added to the expression P. Okay. Polish and reverse Polish notation does not contain any parenthesis. Okay. So 3 to 6, these steps are repeated until the whole expression is scanned, and after that you exit. Now see an example. So consider this expression which is in the infix notation. Okay. So we have what we do, we add a right parenthesis at the end of expression q. Okay. So this is the expression q and we have added right parenthesis at the end of it. Now we have the same, we have now 4 columns. First, the number of symbol. Second, the symbol scanned. Then we have the horizontal stack. And then we have the corresponding expression P written in postfix notation, right? So in the first step, we add a right parenthesis to the end of Q, at the end of Q. And we also add a left parenthesis. We also push a left parenthesis onto the stack. Okay. So in the stack, initially we have a left parenthesis. Now scan the expression Q starting from the left to right. Okay, so first symbol is symbol A. Symbol A is an operand. So if an operand is encountered, add it to P. It is simply added to the output postfix expression P. So A is added to P, right? The next symbol is plus. The plus is an operator. So step 5, if an operator is encountered, then repeatedly pop from stack and add to P each operator which has the same precedence or the higher precedence than the encountered operator. And then after doing this step, that operator is added to the stack. Okay, so plus is encountered. So we don't have any operator in the stack now. Okay, so if we don't have any operator, so nothing will be done. Okay, in the step 5a, and then in step 5b, this plus operator. Okay, what is 5a? This is 5a and this is 5b. Okay, in the 5a, each operator which has the same or the higher precedence are removed from the stack and added to P, and in the step 5b, the encounter operator is added to the stack. So since there is no operator in the stack, so in 5a, nothing will be removed from the stack, but in 5b, this plus operator will be added to the stack. Okay, we push plus sign onto the stack. Now this is the stack position. Next element is left parenthesis. So if a left parenthesis is encountered, then we push it onto the stack. The left parenthesis is encountered, that left parenthesis is pushed onto the stack, right? Next element is B. So when an operand is encountered, it is added to the expression P. Okay. Next element is multiply. Okay, so multiply. Now step 5. Step 5a, remove all those operators which are at the top. Okay, and at the top we have left parenthesis. So nothing will be done in step 5a, and in 5b, multiplication will be added to the stack, right? Next symbol is C. C is an operand, so it is simply added to P. Next symbol is minus operator. So now we now an operand is an operator is encountered. Okay, and at the top of the stack we have another operator multiply, and the precedence of this multiplication is higher than the precedence of the minus. So in step 5a, all those operator which has the same or higher precedence will be removed from the stack and added to expression P. So multiply has the higher precedence than the encountered operator minus. So we will remove multiply from the stack. So multiplication will be popped out of the stack and will be added to the expression P, right? Okay, and after removing multiply, now the top element is left parenthesis. Okay, so we stop step 5a, and in step 5b the minus sign will be added to stack will be pushed into the stack, right? So this is step 5. Next element is left parenthesis, so push it onto the stack. Okay, next element is left parenthesis is already considered. Okay, so this is the repetition of the 8 symbol. So we have already added the left parenthesis to the stack. Next symbol is D. Okay, so D is an operand. So add it to expression P at the end. Then division operator. So step 5. Okay, we at the top we have left parenthesis, so nothing will be done in step 5A, and step 5B. This division will be pushed into the stack. Next element E operand, add E to P. Next is exponent operator. Okay, so now exponent operator, and we have an operator at the top of the stack, which is division. But the precedence of division is lower than the precedence of the exponent. So nothing will be done in step 5A, and in step 5B we add exponent to stack, right? So here division is not removed because its precedence is lower than exponent, right? Next symbol is F. Add F to P operand. Next symbol is right parenthesis. Okay, so right parenthesis is encountered for the first time. So we go back and see the algorithm. So if a right parenthesis is encountered, then repeatedly pop from the stack and add to P each operator on the top of the stack until a left parenthesis is encountered, right? So pop each operator, and this will continue until a left parenthesis is encountered, right? So at the top we have exponent operator, so that exponent operator will be popped out of the stack and added to expression P. Next element is also an operator, division. So division operator will also be popped out of the stack and added to expression P. Okay. Then we found a left parenthesis. So we stop this step, and then we also remove left parenthesis. Okay. So this left parenthesis is also removed, right? So you can see the algorithm. This is step 6A, in which the operators are popped out of the stack and added to P, and in 6B the left parenthesis is removed, right? So then multiplication is an operator. So you in 5A, okay, here the minus is at the top, but the precedence of minus is lower than multiplication, so it will not be removed. And in 5B we add multiplication to the stack. Okay, so this is already done in step 15, symbol number 15. Okay, next is G, add G to P, right parenthesis. The same procedure will be adopted, that operators will be removed from the stack and added to P. So at the top we have multiply, so it will be added to P first, and the next operator is also an operand. The next element is also an operator, so minus will also be added to expression P, and the left parenthesis will be removed. Okay, so now this is the current position of the stack after this step. Next symbol is star. Okay, so star step 5. In a step 5A nothing will be done because the precedence of plus is lower than precedence of multiply. In step 5B multiplication will be added to the stack, right? The next symbol H, operand, so H will be added to expression P. Next symbol is the right parenthesis. Okay, so when a right parenthesis is encountered, you pop the operator, okay, and add to P, add that operator to P. Okay, and this step is kept executed until you find a left parenthesis. So next element is also an operator, so plus is also popped out of the stack and added to expression P. And the next element is left parenthesis. So in step 6B, this left parenthesis will be removed. Now the stack is empty, and you have already scanned the entire infix expression. Okay, so this is the final expression. This is the final expression equivalent to the expression q, which is in the infix notation. Okay, so in this way you can convert an infix notation expression into an equivalent expression in the postfix notation, right? So in the computer, an arithmetic expression is evaluated in these two steps. First, the infix expression is converted into the Polish notation, sorry, reverse Polish notation, which is also called the postfix notation. And then in the second step, that postfix notation expression is evaluated. We have already discussed these two algorithms.